Okay, I'm back, and now we want to talk about curved mirrors. So we're going to take our flat mirror and curve it into two possible shapes. So there is what's referred to as the concave mirror, and then you have the convex mirror. Okay, the concave mirror makes a cave. So if we take our mirror and bend it into a curve, this one's going to be concave. The light is going to be coming from this direction. So the light is over here. It's coming in this direction. It's going to hit the concave. So you see it's making a cave here. And it's going to bounce back. So we're going to use the law of reflection in order to predict where will the light go. And so first, let's pretend that the light is going to hit the mirror dead center. So we can make a tangent to the mirror right here, and that tangent would be straight up and down. So therefore, the light will come in, it's going to hit the mirror, and it's going to go right back out the way that it came in. But what about if there was light that was coming in from this direction? So when it hits the mirror, we're going to need to make a tangent like that. So again, a little teeny tiny flat mirror. The light's going to come in, and then we're going to need to use the law of reflection. So we're going to need to make a perpendicular to the mirror. And then here's our angle right there. So we're going to need to make another arrow that goes like this. And so that means that this angle is going to be the same as that angle. And then you can guess what's going to happen. So we have another arrow that's coming in like this. We make another teeny tiny flat mirror that is going to be perpendicular to the curved mirror here. And it's going to reflect the light in this direction. So where all this light is coming together is this place right here, which we're going to call the focus. So the focus of a mirror is going to be when you have parallel rays of light coming in. And so the light is going to be parallel if it's coming from a very, very far distance. And so what we really mean is sunlight. So sunlight is coming in from an incredibly far away distance. So basically all the light is coming in parallel. And when it hits the mirror, it's going to come to right here. So what would be a good usefulness for the concave mirror? Okay, so a concave mirror is used in flashlights. So if you can imagine that this represents the barrel of a flashlight, then at the focal point, that's where you're going to put the light bulb. So no matter which way the light comes out of the light bulb, you can see that when it hits this mirror back here, the light is going to go in a forward direction. So that would be one reason why you might want to have one of these things. Another thing would be a solar oven. So let's say you want to cook a hot dog, okay? You put the hot dog right there, and then you put this thing outside so that it gets sunlight, and then all of the sun's rays are focused to where the hot dog is, and then you can cook it. So that's an example of a concave mirror. So now let's compare that to the convex mirror. So as opposed to being shaped like a cave, it's shaped like a vex. I don't know. But let's make it like this. And so now the light again is coming in from this direction. And so let's use the law of reflection in order to predict what it's going to do. So let's say that it's coming straight in. And so let's put our flat mirror so that it is perpendicular to it. Well, the light is going to go straight back out. Okay, and then light coming in over here. So now we need to make a flat mirror like this. Okay, and so now the light is going to ricochet off in that direction. And then the light that's coming in like this, we need to make another flat mirror parallel to this curved mirror, and then it's going to ricochet off in this direction. But notice what we can do is we can extend this line behind the mirror, and we can extend this line behind the mirror, and we can extend this one behind the mirror. And so this would be the focus of a convex mirror. So the focus is on this side of the mirror, and this focus is on this side of the mirror. Now you can't reach behind the mirror, so that means that this is going to be a virtual focus, but this one over here is a real focus. You can actually physically touch that, but you can't touch this one because it's behind the mirror. So what would be an example of where a convex mirror would be used? So think about in a hospital. So in a hospital, let's pretend here's the hallway, and then you are going to come up to an intersection like this, and let's say that you're an orderly and you are pushing some poor person on a cart and you're going in this direction. Well, when you get to the intersection, you don't want to get broadsided by another cart that's coming in that direction. So what they do is they're going to put one of these convex mirrors right there. And so this way, light from down the hallway is going to be reflected into this mirror, and then you'll be able to see who's coming. You also notice these mirrors are in grocery stores. And so the idea is that you can see if people are shoplifting. You can look down multiple aisles if you've got one of these things. Now, what's the bad news? So what would be the bad news about using one of these things? Okay, think about the mirrors on the side of your cars. There should be a little sign on the mirror, and it says objects in the mirror are closer than they appear. Okay, so the good news is you have a wide view, but in order to get that field of view, you have to cram it onto the mirror. So things are going to look really, really small in one of these types of mirrors. So that could be a possible disadvantage of the convex mirror. But they both have their usefulnesses. Okay, and so let's take a break, and when we come back we will talk about how we can locate an image in a curved mirror.